And my name is Pavel Rzepa, and our webinar will take around 1 hour with questions. Regarding questions, there's a chat. However, I will disable it for the presentation time, and it will be enabled again at the end so we can do some discussion. And I will be happy to answer any of your questions. So, don't waste your time anymore, and let's go directly to the presentation. Okay. So can you please? Oh, I just turned off the chat. Okay. So, once again, my name is Pavel Rzepa, and today I will demonstrate you the full cyber kill chain against the cloud services, specifically to Amazon. I got an information that that you cannot hear me, so let me do it one more time. Oh. Okay. Can you hear me now? I cannot write anything. Okay, I will enable the chat. Sorry for inconveniences. Okay, perfect. So now, awesome. And can you please just confirm that you can see my presentation? Perfect. Thank you very much. So, let's go straight to the point. So today I will demonstrate the full cyber kill chain of attacking AWS. For long years, we've created from our internal network the real stronghold. For years, we were putting there all kinds of various boxes like IDS systems, CM systems, data leak prevention systems, firewalls, etc. And then there's a decision to migrate to cloud. And the cloud team very often works totally outside of our stronghold. So there's a cloud team, but actually from the organization, nobody really knows what exactly is there. The monitoring is not correlated with CM systems. So the security of our cloud resources is mainly based on the AWS access keys and the belief that our cloud team knows what they are doing and they are not exposing the organization's resources to the attackers. However, those keys may leak in various ways. It was so common that developers were hard coding access keys into the code and then releasing them to public GitHub account. That GitHub created their own GitHub token scanning service. So once the keys are leaked, the GitHub notifies the owner, the provider of the secret. In this particular case, the Amazon, that some keys are probably compromised. In practice, based on the real example, it works like this. So one developer, he committed a new code, including AWS keys. And after less than a minute, he got an email from Amazon regarding the leak. However, please take into account that it is just a notification. Those keys aren't revoked. Those keys aren't disabled. So there is nothing more than just an email with the notification that, hey, your keys are most likely compromised. And after 2 minutes, the developer detected the first attempt to use leaked keys. And so you can see that the bots owned by cyber attackers, they are constantly scanning platforms like GitHub in search of keys. But those keys may leak in various ways, as I mentioned at the beginning. And on this presentation, I want to show you the different way how an attacker can get access to your AWS kingdom. But finding keys is just a beginning from the attacker's perspective. So then I want to demonstrate you all the lateral movements that an attacker can do. So I will show you how it is possible to escalate privileges, turn off monitoring services, how to get persistent access. And finally, after showing you all those threats, I will give you tips how to fix those misconfigurations, as well as how the cloud security assessment, based on everything, how cloud security assessment should look like. Before we go into the details, let me introduce myself. So once again, my name is Paweł Rzepa. I'm the senior security consultant in a company called Securing. On my daily basis, I'm responsible for cloud security assessment, as well as all kinds of pen tests. From time to time, I'm sharing some news regarding cloud securities on my blog, Twitter, and LinkedIn. So if you are interested, I encourage you to follow me. Okay, so imagine that one cloud team, they created the test environment on the company AWS account. So you can see here that the team deployed the EC2 instance. So EC2 instance, for those who are not familiar with AWS terminology, is basically the virtual machine in the cloud. So on this virtual machine, there is deployed the web application as well as the Jenkins. So there's the CI/CD pipeline configured on this instance, and using this Jenkins, they are the developers they are deploying new versions of their web application. To be able to do this, so to authorize Jenkins to deploy new machines, developers have to add a role. So any request going out from the EC2 instance to deploy the new EC2 instance, including the new version of web application, it has to have some permissions. And you can do this by attaching a role to the instance. And this role is stored in metadata. I will tell you in a moment what is metadata and what you can find there, but there's also as you can see, there's also the security group. And security group in AWS works like a firewall. So by default, all the ports are closed. But if you attach a security group, you can open some ports and you can do some whitelisting or blacklisting regarding who can access this port, this service. So what is metadata? Every EC2 instance it has some metadata. And this metadata can be accessed using the link local address, which is 169.254.169.254. This address is a link local address, what means it works only in one network segment. So in other words, it is not routable, meaning that if you have shell to your EC2 instance, you can access the metadata, but outside of the EC2 instance, outside of your virtual machine, you cannot reach this address. Similarly, like the local host address. And in this metadata, you can find all information regarding your instance, like instance ID, like internal addressing, but also the AWS access keys of the attached instance profile, so of the attached role. So now let's switch perspective to the attacker. From the attackers, it looks like this. So he found that there's the web page called domainanalytics.org. And in this web page, you can put IP address or the domain name. Here I'm putting the domain name of the Polish National Lottery website, which was defaced in previous years. The application in the response gives you all the security artifacts related with the domain. This is exactly what is done by the ThreatCrowd application. I will show you in a moment. What is more, if the attacker has the domain name, he can map it to the IP address. And the IP addresses provided by AWS, they are publicly available under those two links. And what is more, you can even based just on IP address, you can know if this is address related with EC2 AWS service or any other service, in which region it works, etc. So from attacker's perspective, he knows that the application domainanalytics.org is actually hosted on EC2 instance. So you can see that the domain name is in the domain parameter in the URL, right? So an attacker, if he changed the address to the metadata, the request will go straight from the instance. So it will give you back all the metadata. Now, carrying the next endpoints of the metadata service, you can see that an attacker can see that there's a security credentials endpoint. Then there's the instance profile attached to this instance name. And here's the treasure. Here's what every attacker will love. This is the access key ID, the secret access, as well as STS token. And for attacker, all those free information are required to be able to authorize any of his actions, of the attacker's action, as the role attached to the EC2 instance. So the next step, to sum up, the attacker found that there's the web application, which is available on port 80 for anyone from the internet. This web application have the vulnerability called server-side request forgery, which allows us to get to reach the metadata, the instance metadata, and there an attacker was able to see the credentials to EC2 role. And this example is based on real story. So there's a website called threatcrowd.org, and there was reported a vulnerability that it was exactly it was possible exactly what it was showed in the example. So basically, if you put as a domain something else than if you put the metadata IP address in the domain, the attacker was able to see the credentials of the role. And if you are interested, all the details are written here under this link in source. But finding keys from the attacker perspective is just the beginning. So the next step every attacker would like to do is to determine what can be done using those keys. And all those 4 AWS commands, the attacker has to use all those 4 commands to get to find out what he is allowed to do. So firstly, he has to use the get caller identity, and you don't need any special permissions to call this action. Everyone is allowed to use it. Based on that, we know the role name, and then using the list attached role policies, we are getting the name of the name of the policy. And then you have to use the get role policy to finally find out what permissions are assigned to this role. So as you can see, there are many steps that you have to do manually. So it's much easier and it's much more effective to use some tools to automate such actions. And one of those two tools is Pacu. It's the AWS exploitation framework. You can see the link to this GitHub repository. And basically, it works like Metasploit framework. If you know it, let me show you how the Pacu looks like. So it's written in Python 3. You can divide every session. So, for example, if you are doing parallelly some projects, then all the findings are stored in separate sessions. So you can see that there are various comments, and I will show you in practice how they work. So first of all, an attacker will import the keys. So the same keys that were found in the metadata service, now we are importing to Pacu. So the AWS access key ID, the secret access key, as well as session token. Then we have to specify the region. And if you remember, the region can be known from the IP address. So using command ls, you can see all the modules that are available in Pacu. And those modules are the automated actions, like EC2 enum. Instead of running few commands from your AWS CLI, you can simply run the module EC2 enum, and if you are allowed to, it will grab all the information and present you in and then display you in the console. So in our case, it wasn't possible. It wasn't possible to get them to simply ask what permissions, what policy is attached, because it is very rare. It is pretty rare that that there is a role with IAM permissions, with identity and access management permissions, which are attached to the role. So the other way the attacker can determine what permissions are assigned to this role is simply brute forcing. So if you can see in Pacu, you are just running the IAM brute force permissions module, and it will give you as an output what permissions you have. And it seems that, as you can see in the policy, that there's attached the policy with the EC2 and the wildcard. The wildcard means any action. And this is pretty common because it's much easier and quicker from the developer perspective to give such permissions. Although it is over permissive, usability of it is much more convincing for developers. But this is really a big security issue to give permissions in those ways, because you never know if if Amazon is not releasing new services, and then you are not totally aware that you are giving the special permissions because of usage of those wildcards. So if the attacker knows that we have the full EC2 permissions, then time for enumeration. So the attacker runs the EC2 enum module, get all the informations regarding enum, and then to display those information, you should run the data and then the name of the service, so data EC2. In the output, which was pretty big, and I don't want to bore you with that, the attacker finds that there's also one stopped instance with the instance ID, as you can see, I08, blah, blah, blah. But the stopped instance has the instance profile admin. And the name sounds that this role assigned to this instance is much more permissive than this what we have. In other way, so we have the EC2 role. We found a new stopped instance, but how to get there? How can we get into this new EC2 instance with higher privileges? The answer is by using user data. So every EC2 instance has their own user data, and you can specify there the bash scripts, which will be executed at the boot initialization process. So once the new EC2 instance is launched, then all those scripts from user data will be executed. And it is, of course, very helpful for developers, because once the new EC2 instance is deployed, then it may, for example, update all the dependencies already pre-installed on this instance. It can take a new code from the GitHub repository, etc. The problem is that user data by default are executed only once, only at the boot initialization process. So if the EC2 instance has been run and then stopped and run again, it will not, the user data will not be executed the second time. The solution is to use the Cloud Boot Hook directive. And if you see here on this slide, the Cloud Boot Hook directive, and then there are some bash instructions, like the bash one-liner, which is basically the reverse shell. And this will, adding the directive Cloud Boot Hook will force the EC2 instance to run user data every single time the instance is restarted. So once you stop the instance, change the user data, and then run the instance, then this user data will be executed every single time the instance is run again. So to summarize the plan of the attacker, so the attacker has the EC2 role access keys. Using it, the attacker is able to modify the user data, then to run the instance, and once the user data will be executed, the attacker gain the reverse shell, and using the same trick to access the metadata of this new EC2 instance, the attacker will be able to get the new permissions, most likely the administrator. In Pacu, you can do this using the EC2 startup shell script. So instead of doing it manually from the AWS CLI, let's use this EC2 startup shell script module. As an argument, you have to give the script, so the bash instructions that you want to put in your new user data. Here, and here you can see that I was curling if config me. So if you want to see from the terminal your external IP address, you can use this command like curl ifconfig.me. So this is the public IP address of the attacker's machine. So the attacker creates the file refshell.sh, in which you can see that there's the reverse shell. So once user data will be executed, then the reverse shell will be sent to this address and to the port number 1337. So the attacker set up the listener and then run the EC2 startup shell script module in Pacu. So you can see that this module basically is responsible for stopping your instance, modifying the user data with the new script, and then starts the instance, which will force the user data to be executed. So here you can see that the attacker set up the netcat listener, and if we are lucky, the attacker will catch the reverse shell. Yep, it's just happened. So now, if the attacker runs the command curl to carry the metadata service and to security credentials, now you can see here that the role assigned to this instance is the admin instance. I took this example from the real case. So during one during one pen test I was doing, I found that it was stopped machine with admin access, and later I asked the developers, why are you, if you are not using it for years, why are you still keeping this stopped instance with admin permissions? And they said, well, it was just for tests a long time ago, but now nobody is looking into it. So it was a great attack vector to escalate my privileges. So what are the next steps? The attacker obviously wants to disrupt any monitoring service. And monitoring in AWS is by default done by CloudTrail service. And this CloudTrail service is monitoring all the regions by default. And all the logs are then stored in the S3 bucket. However, if the attacker has proper permissions, like administrator that we've just found, then he can modify the CloudTrail service to monitor only one region. So if the attacker then launch the cryptocurrency miner in every other region, nothing of those actions will be monitored by CloudTrail. And of course, you will not see any of those actions in the logs from CloudTrail. The other way the attacker can disrupt CloudTrail is to remove the bucket containing logs or remove the trail. However, those two actions are very loud, so probably the first idea will be the best. And again, in CloudTrail, you can do it. You can do this in just few comments. So firstly, you have to enumerate the monitoring services, and it will give you in output what monitoring services are active. And by default, you can see that flags like include global service events. So there are in AWS, there are services like identity and access management, which are global. They are not region specific. And there's a special flag to include such global events, like creating a new identity and access management user, or, for example, to monitor only one region instead of all. Currently, you can see the default configuration, so the global service events as well as multi-region trail, those flags are set to be true. Then, an attacker ran the detection disruption module, and thanks to it, thanks to Paku, the attacker can either disable the trail, delete it, or minimize. And minimizing is probably the best way, because even the legit administrators will not be notified about those changes. Once the disruption monitoring service module is run, then you can see that the flags has been changed. Like the global service events are set to false, and only EU West 1 region is monitored. So if the attacker will do some action outside of this region in any other region, those actions will not be monitored by CloudTrail. And also, if the attacker creates a new identity and access management user, this will not be included in logs. The next step would be to persist access. So attackers doesn't want to do some bad actions and then go away. Usually, all the attackers want to have the persist access to get back to this cloud infrastructure later when they start the attack campaign. You can persist access if you are inside of the cloud, inside of your AWS account. Then there are numerous ways how to persist access. One of them is simply create the shell in user data as in the same way as was done in my demo. There's also a way to, for example, if there are multiple Lambda functions, nobody probably detect that a new Lambda was added, and this Lambda you can code it to be triggered once some action happens. So, for example, if the attacker sends a specially crafted HTTP request to API gateway, then this attacker's Lambda will be triggered, which will create the IAM user with administrator permissions, and the credentials will be sent directly to attacker. Other way is using the trust policy. It is in role-based access control. It is pretty common to use trust policy. And in trust policy, you can specify who can assume the role. And from my experience, it seems that the policies are not audited at all. So nobody probably detect that in your trust policy there's added the ID of attacker's account. So the external attacker's AWS account will be allowed to assume your role. And last example of persisting access is adding the extra keeper to already existing users. And in Paku, you can do it using the IAM backdoor users keys. And this module basically creates an extra access keeper to every single user. And in AWS, every single user can have 2 access keys, because it's done when you are rotating the service. So imagine that when your service, like the Jenkins client, is using the keys, but then you want to change those keys. So instead of turning off the service, modifying keys, and then starting it up, you can apply the second keeper and then turn off the first one. So there will be no interruption in serving the service. What is even more scary is that once the attacker creates the second keeper, nobody is notified about it. So you can see that there's an Elliot Alderson user, and the access key age is 5 days. What is more, it has even the virtual multi-factor authentication assigned. So from the administrator perspective, it may seem that everything is good and all right. However, in the security credentials tab, you can see that there are specified 2 access keepers, and the presented and the date of creation is presented. The date of creation is coming from the older keys, so from the original keys, but there's absolutely no notification regarding amount of assigned keys, and the new keys was created. So you can see the difference in the date. It was the 28th of April when it was created, but as you could see in the beginning, the access key age is 5 days. So it is referring to the older key pair. So how this scenario could end? There was such real story, and it was related with the Codespaces company. If you don't know it, Codespaces was a company, was an alternative to GitHub platform, and they were very promising. They have all the whole infrastructure of Codespaces were run in AWS. However, the keys of administrator has leaked, and the attacker blackmailed the owners of the Codespaces. Basically, the attacker said, "Hey, if you give me if you give me some money, then I will give you back those keys which I found, and if you don't do it, you will have problems." So the owners of the Codespaces have done some forensics stuff, and they found that indeed one of their administrator account was compromised. So what they did? Simply removed the access of this user, believing that it is the end of the story. However, the attacker, when he saw that they are removing his access, he already has some backdoor, and he used this backdoor to get there again and remove all the resources that were created under this account. Unfortunately, people from Codespaces, they stored under one AWS account all the resources, including backups. So the story ends that the Codespaces stopped existing in just one day, and all the people lost their job. Now, we talked about attacker perspective, but but how can we defend against such attacks? First of all, there were so many server-side request forgery vulnerabilities and such attacks of taking keys from instance metadata. There were so many of them that Amazon created the instance metadata service version 2. They announced it in November of 2019, and they said it's the remediation for such attacks. But I want to show you how this metadata service version 2 works in practice. So yesterday I set up a new EC2 instance. So here I'm getting a shell. Because some of you may think that this metadata service version 2 is applied by default, which is not true. If you see on my newly created instance, I'm still able to access the metadata service, because unfortunately you have to explicitly disable the metadata service version 1, and then you will be indeed robust to such attacks. So you need to have the instance ID, and you have to, unfortunately, you have to apply it on every instance. Of course, you can automate it, uh, it requires your code. So using the command modify instance metadata options, you are able to add the HTTP token required flag. And if it is set to required, then there's needed an additional token to access metadata service. Sorry. Okay. So if we run these modify instance metadata options with HTTP token required option, you can see HTTP tokens required. And if we try now to access the metadata service, I'm getting the unauthorized error. So to access the metadata service, you actually need to use the put method firstly to get a token. So let's analyze this comment. There's the put HTTP method used with the header x AWS EC2 metadata token TTL seconds. So to set the expiration of the token. And it is in the metadata. The token is the token is available under this latest API token. If you run it now, then in the environmental variable token, you will have this token that can be used by your application. Now, if we echo the token environmental variable, you can see this token. And now to access metadata service, you need to use this token. So you are using the x AWS EC2 metadata token header. Then there's a specified token, and then you are accessing latest metadata. And only now it will the comment will give you the access to metadata. So from the attacker perspective, if you are using the metadata service version 2, it is not reachable. So nobody will be able to use the SSRF vulnerability to access your metadata. Furthermore, the security best practice is not to use just one account. You can use, for example, AWS organizations to separate the accounts. For example, all the development stuff will be done under developer account. What is more, you can apply the SCP, the service control policies, to deny some actions. So nobody from the developer account, even administrator, will not be able to perform some actions, some specified actions. For example, turning off or modifying CloudTrail. What is more, all the misconfigurations like giving wildcards in IAM policies or giving the public access to test application should be found by the CIS Foundation's benchmark. So basically, it is a list of best practices, AWS best practices, that you can simply check if you are following those best practices. And last thing that the developers should do is to monitor the security events. Unfortunately, in AWS, you have not only CloudTrail, but you have more services related with monitoring security. So CloudTrail only monitors the calls, the actions done by users or roles. However, you will not see there, for example, the traffic coming to your application. You need to enable VPC flow logs to see this. And all those services to monitor security in your AWS account can be aggregated using the Security Hub through another AWS service. So based on the example, how can we detect all these security issues? How to create the process of cloud security assessment? First of all, you should do the architecture review. If there are any undocumented resources, if there are any flaws. For example, one of my case was to detect the in customer infrastructure, to detect that there was running the cryptocurrency miner, and customer was totally unaware that there is working such thing for months. The next step would be to detect all the misconfigurations. So you can use the CIS benchmark, or you can use the open source tools like Prowler, Scout2, etc. And finally, the last step, how can attacker can access your AWS account, are the vulnerabilities in your services, like deploying the serverless application with vulnerability, or the application hosted on EC2 instance, on Elastic Beanstalk, etc. So all those applications require additional pen testing of those services. And finally, even if everything is configured correctly, without monitoring, we cannot say that you are secure, because you have to also take into account that some of your developer can be compromised, and then what? So you should monitor all the sensitive actions that are done, and of course have specified the incident response procedure. As you remember from the beginning of this presentation, when there's a key hard-coded in your code and then released in GitHub, you don't have time for logging into your account, then verify what is happening. It should be done automatically. That once the keys are compromised, those keys should be revoked or disabled. So, to sum up the presentation, remember to audit your cloud infrastructure. Then harden it, fix all the misconfigurations, and remember, it's a process. It's not just a single time action. That's all from my side. Here are, so let's stay in touch. Now, if you have any questions, I will enable chat. Oh, it's okay. Right. So if you have any question, I will be happy to answer it. So please let me know. I also would like very much to give you the survey, so you can simply give me some feedback if you like this presentation or not at all. So I will be very, very thankful for filling this survey. Meanwhile, if you have any questions or want to discuss anything, please just write your question, your topic in the chat. So regarding recording this session, yes, it will be recorded and I hope soon released. You will get, after this presentation, you will get an email. And in the email, I put the link to my guide with the AWS security best practices. So hope it will be helpful for you. The truth is that the real problem, and it's not related only with AWS, but with all cloud services providers, that you can see, you can find a lot of help in the documentation, but you will never see all the threads in this documentation. So you have to, unfortunately, you have to go through for the third-party resources to understand the real threats. My favorite one is that by default, even if you remove all the security groups or the network access control lists, then you are still able to get out from the EC2 instance using the Amazon DNS service. But I don't want to mess up now with that. If you like it, I can prepare the next webinar with those hidden threats in cloud. All right, there's a question. If you want to hack your own AWS site, do you need permission from Amazon? Yes and no, because that depends. For example, if you are running the static content of the web page is stored on the S3 service, and by mistake you will give the public write access, then the attacker, without any permissions, he can overwrite every resource, every picture that is presented on your website with any content, and it's a real threat because it's a real threat because I've done the research by myself, and I found more than 1,000 buckets with the right permissions. And some of them were exactly like the buckets only for the static content of the web pages. And I could override every of it. Okay. Thank you for answering the survey. I went to the question and Q&A mode. So I will make it visible to everyone. Hope everyone can see it. Yeah. What about security issues from cloud? I believe it's cloud owners itself, data spying, etc. Well, it's the big problem. Because in AWS, for example, you cannot encrypt the memory. So, for example, if you are doing very sensitive operations on your EC2 instance, theoretically, Amazon, by having the physical access to the machine, can get all the secrets from the memory because you cannot encrypt there. Azure, I know that he's supporting such encryption. However, it is very important to encrypt data. And if you know the shared responsibility model, you should know that the responsibility for encrypting data and for securing your data is on you, not on cloud service provider. So using, for example, key management service, the KMS, you can import your own keys your own key material, and then using it you can encrypt your data, for example, data in S3 buckets. So then nobody without a key will be able to access this data. Okay, there's a next question. Let me public it. Other than the knowledge of AWS architecture, are there any other skills that can help you with the same pen testing mindset you have applied in the example you shared? Are there any other skills that can help you with the same pen testing mindset? I don't know if I understand your question. However, yeah, other skills for sure, they can be used when attacking AWS. For example, phishing scenarios. It is really, for me at least, it is really fascinating. How can you attack using the phishing your team? Because if you log in to your AWS console in the browser, please take a look that there's the remember me, right? Now, if you have the multi-factor authentication attached to your user, the attackers can still make the phishing domain and put there the login page to Amazon console. And if you have virtual device instead of the physical one, like the YubiKey, then this persist cookie that is enabled by an attacker will allow him to get access to your AWS, even if you log out, if you change your password. So for next, I think 9 hours, an attacker can access your whole environment using your permissions. If you are interested, just write me an email, and I will give you the URL to whole article regarding this scenario, this phishing scenario. All right. Okay. I don't see any other questions, but if you have, I'm very open to discussion, so I will be very happy to talk with you. I want to ask you for last thing, so to fill up the next